I know that was a very abrupt cut off, but when I turn off my camera app, it shuts off. And I think 10-minute length videos are the perfect length. And by the way, mass of electron is 1836.15 times smaller than proton. So mass of proton upon 1836 is equal to mass of electron. Yep. All right. Next is the formation of nucleus. You may have not learned this because it's not exactly in the syllabus, but I will teach you this anyways because I want to, and it's really interesting. Formation of goddamn nucleus. Yeah, formation of nucleus. So what is a nucleus? Nucleus, well, let's first write the equation for energy because this is really well, let's just firstly study what is a fucking nucleus. Yeah, let's study what is a nucleus. So a nucleus is this. It has protons and neutrons and outer shells with electrons. So this part inside, which has protons and neutrons, which are called nucleons, is the nucleus. How is the nucleus formed? Have you ever thought about that? What holds these two together? Why is the proton attracted to the proton rather than repelling against each other? Why does the nucleus stay stable? How does it stay stable? Well, I'll try to answer most of those questions. But first, we have to know that E equals to mc squared. What is this? It is the energy mass equivalence. This was given by Einstein, as you know. But we only thing we need to know, this is the energy mass equivalence. It has not much, it does not have much use to us at this moment of time, but it is really interesting. So protons are almost always found in the nucleus and not present in free state most of the times. How does a nucleus form? That is our topic. So this is a proton and this is a proton. To form a nucleus, they have to go towards each other now. But these both have positive charges. So they should repel, right? Yes, of course. But have you ever tried to join two of the like poles of a magnet? Have you ever tried to join two like poles of a magnet? I think you might have tried to join at least two poles of the like magnet, the like sides of the magnet. What do you do to try to join it? You apply more force. That's not an option. You increase the speed. Yep. You increase the speed. So these two go together, go at each other at very high speeds. Yeah, high speeds. Now, when this happens, when these two go towards each other at very high speeds, the proton loses some of its mass. Not exactly loses, because mass is always conserved. You may have heard of that principle, the law. Yeah, mass can never be created nor destroyed. So where does this mass go? This is approximately 0.7 of mass of proton. Yeah, this amount is approximately 0.7 mass of proton. So this mass is converted into energy, which bounds these two together. This energy bounds these two together. This is nuclear force or bonding force. Nuclear force or bonding force. That is why they don't, well, they of course do repel each other, but the bonding forces magnitude is very high, very, very, very high. It is like 10 to the power 10 times or 35 times the force of gravity, but it's applied in a very small space. That's why you don't feel it. It is very interesting. As I said, binding, not bonding. Binding force. Yeah. Now, as we can tell, this will lose some of its mass and it will be converted into energy. So, what is the mass in here? As I said, I missed some of the places. Oh god. Anyways, as I told you right here, where the fuck is it? Yeah, right here. That the mass of proton is 1.672, but we have learned that it is 1.66 in schools, right? 1.66 into 10 to the power minus 24 grams, or 1.66 into 10 to the power minus 27 kilos. Why do we learn that instead of 1.67 into 10 to the power minus 24 or minus 27 kilos? Well, that is because this mass lost, let's say mp dash is equals to mp minus mp, this is mass of proton, mp into 0.7, because this is the mass lost. So if you calculate this, this will be equal to approximately equal to 1.66 into 10 to the power minus 24, 10 to the power minus 27 kilograms, or 1.66 into 10 to the power, this is 0.993, sorry, 0.993, 1.6 into 10 to the power minus 24 kilos. Yeah, got it. Now this value right here is 1 AMU. Now if you have studied this topic before, you may know it is 1 AMU is defined as 1/12 of 1 carbon 12 atom, weight of 1 carbon 12 atom. So basically what that is saying, because there are 6 protons and 6 neutrons, when you add protons plus neutrons, that is equal to the molecular or the molecular weight of the compound. Yeah, we know that proton plus neutron equals to molecular weight of the molecule, compound, whatever. Yeah, so basically there are a carbon atom is represented as C612, where 6 is the atomic number, which is also equal to number of protons, and M, this right here, is the mass number, which is equal to proton plus neutron. So the mass of 1 carbon 12 atom is 12. So 1 by 12th of 12 is 1 by 1. Yeah, and 1 mass of proton. Yeah, 1 mass of proton. So 1 into 1.66 into 10 to the power minus 24 grams. So that will be equal to 1 AMU. Got it? That is how you find 1 AMU. 12 AMU upon 1 1, yeah, that is what basically did. Sorry, upon 12, so 1 mu. It's why did they choose carbon exactly? This is for the board's purpose, or just uh, because carbon is a more stable atom. That is there is a whole like chapter based on just carbon. So not a chapter, a whole section of chemistry just based on carbon. So carbon is very very important. So, as I, goddamn, that page flew away. As I told you, A, Z, sorry, XA. A is the mass number, which is equal to number of protons plus number of neutrons, and Z is the atomic number, which equals to number of protons. Yep. Now, to find charge on an ion, or number of electrons or protons. Number of electrons on a cation. A cation is a positive ion. So let's say Al2 plus or whatever is number of protons minus charge. Number of protons in this is 12, I think, or 13. Is it 13? I'm forgetting. I think that's 13, right? Yeah, 13. So this will be 13 minus 2. So 11. Number of electrons will be 11. And in an anion, it will be number of electrons will be equal to number of protons plus charge. Yep. Now let's talk moles. What exactly is a mole? God damn, please focus up, man. A mole is a number, is a quantity which is given by Na. This is also Avogadro's number. It is equal to 6.023 into 10 to the power 10 to the power 23. Yeah, that's it. Sorry, 24. No, 23. I'm dumb. Oh god. It's 23. I should trust my gut more than I trust myself. So, basically, how did we find this? So, you want to convert 1 AMU into grams. Yeah? How do you do that? So, we know that 1 AMU is just 1.66 into 10 to the power minus 24 grams. Yeah? And this is 1. So, something multiplied by x is equal to 1 upon 1.66 into 10 to the power minus 24, which will be equal to 0.6023 or something, 0.6023 into 10 to the power minus 10 to the power 24, and this will be equal to 6.023 into 10 to the power 23. That is how you get this. So we can draw a relation through this. 1 Avogadro's number is equal to 6.023 into 10 to the power 23. So 1 Avogadro's number will always be equal to 1 upon AMU. Yeah? All right. Now, let's talk about types of masses. Yeah? Types, goddamn work, of masses. There are very many types of masses. Yeah? There's first two we have already learned. First is the AMU, which is just mass of one nucleon. One nucleon is, as I told you, a proton or a neutron, basically the same mass. So yeah. Two is the atomic mass. Atomic mass, which is mass of one atom. Mass of one atom in AMU. Yeah. Next is the molecular mass, which is mass of one molecule. Mass of one molecule. This is also in AMU. Fourth is the molar mass. Molar mass, which is mass of one mole of atom. Mass of just mass of one mole. Yeah. Next is the relative atomic mass. The relative atomic mass is it does not have a unit because it gives the relative atomic mass. So let's say you have a carbon 12 atom, so its mass will be 12 AMU. So the relative mass will be 12 AMU upon 1 AMU. AMU to AMU gone, and that will be 12. So it's just the numerical value of the thing. Yeah. Same thing, relative molecular mass. Same thing same thing will apply to relative molecular mass. I'm not gonna write that down because that should be self-explanatory. Next, we'll study gram atomic mass. Yes, gram atomic mass, and we'll have gram molecular mass, then average atomic mass, and then I think we should end the lecture. Yeah, because then I have to study off my own. I've of course studied this chapter. I know basically everything about this chapter. I just want to, revise myself because I'm a 10th grade student, just like 11th grade student, just like you. Atomic mass. This is basically for my revision. Mass of one atom expressed in grams. Basically, molecular mass of one atom. Molar mass, sorry. Eighth is the gram molecular mass, same thing as the above statement. Now, what does 1 gram atom mean? It basically means 1 mole of atom. What does 1 gram molecule mean? It basically means 1 mole of molecule. Yeah. What is average atomic mass? Average atomic mass. So we know that chlorine has a molecular weight of 35.5, right? Chlorine has a molecular weight of 35.5 AMU. It's actually 35.45, but yeah. Chlorine has a mass of 35.45. But how is that possible? We know that the every proton and neutron weigh the same, which is 1 AMU. So how the hell do we get one chlorine atom's molecular weight as 35.5? That is a very good question. So this is due to average atomic mass. Yeah. So there are two types of chlorine atoms mainly found. The first type is the chlorine 3517 and the second type is chlorine 3717. Yeah. This is very massively present. This is 75% in nature and this is about 25% in nature. So this is the relative abundance, by the way. Relative abundance. Don't get confused if a question says relatively abundant as 75 and 25 or 3:4. So the average atomic mass is given by m1 into percentage 75 into m2 plus m2 into 25 upon 100 percentage. This is the formula. So if we apply this formula on this, 35 into 75 plus 25 into 37, yeah, this will be equal to approximately 355 upon 3550 upon 100, and this will be equal to 3550. So 35.5. We can do this with multiple elements. Let's say boron. Boron is present in two forms, boron 11 and boron 10. Boron 10 is of course less present and boron 11 is more present in 81% of this. And same with hydrogen. Hydrogen is 90 H1 is 99.98, H2 is 0.0156. Yeah, I think it's 0.0156 or something close to that. And tritium, which is also a radioactive material, which we will talk about in the next class. Why is it exactly radioactive? But it is present in 10 to the power minus 15%. That's why we take the molecular mass of atomic mass of hydrogen as 1.008, if you have seen the actual mass. Yeah, so I think we will end the lecture here, and I'll see you next time. Goodbye. Next time we're going to study nuclei.